Part 2, in behavior and turning points, okay? So for in behavior, there are steps to describe the in behavior. First, you're gonna write it in standard form. Second, you're gonna identify the leading coefficient, okay? Your leading coefficient is the number with the highest power, the variable with the highest power. Okay, if it's positive, it means it ends positively. So that means that your end is going to be going towards positive infinity. If it is negative, it means it ends negatively. That means the end is going to be going towards, it's going to be down, heading towards negative infinity. The next thing is identify the degree of the polynomial. If it's an even, then the beginning and end behaviors are the same. Okay, so if I end it positively, I'm going to start positively. If I end it negatively, I'm going to start negatively. Their end behaviors are going to be the same. Odd, the beginning and the end behaviors are opposites. So if I end positive, that means I had to start negative. Going down. If I end negatively, that means I had to start positively. They're going to be opposite behaviors. So a good thing to remember is odd, opposite, even, same. Okay? Turning points. Turning points are when the graph changes directions. Okay? Changing direction means that I go from being increasing to decreasing and decreasing to increasing. But first thing first, the maximum number of turning points is the degree minus 1. So an example, if I'm a third degree, my max TP, my max turning points is, it's either going to be less than or equal to 2. Because it's the degree minus 1. Okay? So turning points visually mean, for example, if I have a quadratic, it goes like this, right? This is a turning point because I went from being decreasing to becoming an increase. Do we see that? I changed direction. So I went from decreasing to increasing. That's what a turning point means. All right. So let's look at some teacher examples. So these are examples of even turning points. So if you notice here, my my leading coefficient equals positive 4. So I end positively, I end going up. My degree equals the 4th degree. And so it's an even degree, which means that how I end is how I also start. So my end behaviors are up and up. Cool? Okay. As you get further into pre-cal, you guys will write it more formally. But for us, this is what's happening. Our turning points. So turning points I'm looking for, when do I change directions? So I have students typically draw the arrows. I'm a decrease, I'm an increase, I'm a decrease, I'm an increase. So I change directions here, here, and here. So if I was to graph this, I would see that I had 3 turning points. Okay, as you get further into math, these turning points are going to be called your local maximum and minimums. Your local extremis. Okay, and the reason why these are my turning points is because I am decreasing, increasing, decreasing, then increasing. These are my change in direction. Okay, this one, my leading coefficient is -1, which tells me that I'm going to end negatively. The degree equals 2, which tells me that however I end is how I'm going to begin. The degree is 2, so my maximum number of turning points is 1, and I only have 1. I increase, then I decrease, so that means I have 1 turning point right here. How do we feel about the even examples? Okay. Odd examples. So on our odd, our leading coefficient here equals +1. Our degree equals 3. Okay. So it's positive. So it ends positively because it's odd. I ended positively, so I have to start negatively. So my end behaviors are up and down. They're opposites. At no point do I stop. I increase, I increase, I increase. So at no point do I change directions. So notice how there are 0 turning points. And that's because the graph is increasing for all of the x's. Do we see that? All right, let's look at this example. My leading coefficient now is -1. My degree is still 3. So my leading coefficient is negative, so I end negatively. My degree is odd, so I start opposite. So my end behaviors are up and down. And I'm going to track when I increase and when I decrease. I am decreasing, then increasing, then decreasing. At what points do I change directions? Change here and here. So that's why there are 2 turning points at these locations. All right, what are your questions between identifying end behaviors and turning points? Okay, cool. So here are the 3 that I would like for you to practice. So identifying the leading coefficient, the degree, tell me what's going to happen with the end behaviors. Okay, so on the first one, my leading coefficient equals 4. My degree should be 3rd. So since my leading coefficient is 4, I know it's +4. I'm going to start, end. I'm going to end positively. So I'm going to end up. And my degree is 3. So because it's odd, it's going to be the opposite of that. So that means I had to start down. Okay. On the second one, our LC is -2. Our degree is 4. So my LC is negative. So that means I start down. And my degree is even. So that means I'm going to do the same behavior. So I end down and I start down. On 3, my LC is negative. My degree is 3. So that lets me know that I'm going to be doing opposite behaviors. So if I end down, then I have to start up. And that's how you predict the end behavior using the function. How do we do? Cool.